So hi guys, today we'll talk about Keras Hub image examples. So here we are doing image classification with TensorFlow Hub. Uh, so first we'll start with importing our libraries, then loading a pre-trained image classification model. We are using a pre-trained model from Keras application, then create a base model from MobileNet V2 and we'll print model summary. As you can see, it printed various layers, input layer, convolutional 2D layer, and many more. Then we'll move on to image preprocessing and prediction. So here is it is making a function of load and preprocess image, then visualization of the test image, make a prediction, decode and display up top 5 predictions. As you can see, this is the test image and it will generate all the information of it like military uniform suit, insert eye, wear skin, ball player, then processing multiple images. It will import all the libraries, then load the model function to load the pre-processed image, download sample images, and will show the graph of it. As you can see, top prediction from H1 is military uniform, and top prediction from H2 is laboratory retriever. Then we will visualize the intermediate layer activations. So for that, we'll create the model that will output the activations of specific layers, and create a model to output the activations of specified layer. Uh, get a sample image, plot the activations, and visualize activations. As you can see, we'll visualize all the activations channel 0, 1, 2, 3, all the way to 15. Then we'll do feature extraction and transfer learning. We'll create a model for feature extraction, compile, print, model summary. As you can see, all the layers are printed. Then we'll prepare a small dataset for training. We'll import, load, get, class, define, create training dataset, visualize the images. As you can see, we can visualize all the images, let's say tulips, sunflowers, roses, dandelion. Then training the transfer learning model will define callbacks for training, train the model, plot the graph. As you can see, the graph of model accuracy and model loss, evaluating model performance on the new images, will define function of predict and display. Then we'll download the test image. As you can see, we got the image and also predictions as well. There it is sunflower, if that's correct, then we'll fine tune the model. We'll unfreeze the top layer of the base model, continue training with fine tuning and plotting the graphs. As you can see, uh, it has a graph as well at last. Then we'll save the model, load the model. Yeah, and we'll print the original model prediction and loaded model prediction at last, which is sunflower and flower. That's correct. Then we will move on to Keras Hub text. So we'll do text classification with Keras here. We'll import all the necessary libraries, load the IMDb dataset functions to convert integers back to words, print it, compile it into model summary. This is a model summary. Then we'll train and evaluate simple text classification model. Select the training dataset, train the easy model and plot the graph. This is the graph of it. Text classification is key at the intermediate level. In the intermediate level, we'll do compile the model, model summary, train the intermediate model, evaluate and compare the models. As you can see, this is model summary. We're training it and we're comparing it. Then text classification keywords in this advanced level. So in this we use bidirectional LSTM, compile the model, so model summary, and train the model and evaluate it. Model summary, as you can see, train the model. Now text classification keywords in expert level. So We'll import libraries, custom attention layer, define the model architecture first, bidirectional second, concatenate, read the model, compile model, show model summary, and save all the models. This is all the summary, and we are showing all the models. And then we make predictions on our trained models. We'll make a function of pre-process text, then a function to predict sentiment analysis, sentiment using any of our models, text with example reviews. As you can see, sentiment, confidence, and raw score. All text classification examples are completed. Then we'll move on to hand gesture recognition using teachable machine concepts. For that, we'll import all the required libraries, then we'll do data collection, create function to collect and process image data, resize all the stuff, all the modification, then function to create directories for different texture classes, collecting training data, will collect image samples for each texture class, take photo display, show the captured image. Uh, as you can see, I have shown thumbs up, sample 1, sample 2, sample 3, all the samples of thumbs up, thumbs down, then peace, open palm, closed fist, all that stuff. Then we'll move on to data preparation. Here we'll create image data generator for training data, then get class labels. We'll move on to model architecture, and that will build the CNN model for hand gesture recognition, compile the model, create the model displays, model summary. This is the model summary. Then we move on to model training, and this will train the model and load the best model possible. We are training the model here, evaluating the model performance by plotting the graph. So we'll plot the model accuracy and model loss, as you can see. Then we'll test the model. We'll make a function, predict gesture, and show all the graphs. So this show compound and various graphs of different things like close space, open palm, page, thumbs down, thumbs up, and then we'll export the model. Uh, we'll create a simple HTML interface for the model. As you can see, this is the HTML file of the model. Yeah, and then we'll import all the libraries, and that's all. This is our model, and we have downloaded zip file as well. Then we will move on to audio classification. Here we will import all the libraries and audio feature extraction. We'll define audio processing functions, convert to log scale, then dataset preparation. Here we'll explore the dataset, print the dataset info, forward data processing. Then here we will prepare data with fixed size features. As you can see, modify function convert to numpy arrays, prepare the dataset, model architecture. So build and train the CNN model for auto classification, split data, convert labels to one hot encoding, build the model, compile the model, print model summary. This is the model summary. Then we move on to model training, train the model and evaluate the model. This is training. Then evaluation. This is uh, showing all the visualization. As you can see, model accuracy, model loss, and confusion metrics. Then we'll test the model by defining a function named predict audio class. Test with simple audio. Then we'll visualize it. As you can see, spectrogram, confidence scores, another spectrogram, and confidence score. Then we'll export the model, and at last we'll download the zip file of the model. Then we will move on to text classification. Here we will import all the libraries and install the libraries which are required. Let's say sklearn. So And then we'll import the dependencies. Then first we'll define simple text and labels, then reprocess text data and labels. We'll build the emotion classifier model. This is the summary of it. Then we'll train the model, test the classifier on new phrases. Then we'll visualize the model accuracy, as you can see, model performance and power. So this was all about Keras and this audio classification and text classification. Thank you so much for watching.